Hey everybody, it's Shane from Wright and NSW PEP. We're going to continue talking about power management, so let's go down the line and let's talk about busways and bus duct. Let's get started. Before I get into busways, let's talk about how data centers traditionally run power cabling. So power would come from the UPS to the PDU. Then power from the PDU would be distributed to the racks by long lengths of cabling. This cabling would be run under a raised floor or in overhead cable trays. If you've seen a data center, it typically looks something like this being the underfloor and this being the overhead trays. Let's move this up. The challenge here is that the raised floor is also used to distribute cooling to the racks. As more and more cabling is installed in the floor, you start to lose room for the airflow, or you could even block the airflow completely. And even in overhead racks, there's only so much cable that'll fit. It's also harder to add circuits, to add or make changes in the data center layout or capabilities. So let's move this over and let's talk about busways. A busway or bus duct is a self-contained enclosed modular system for distributing electrical power. The busway allows you to click and connect prefabricated sections instead of pulling long runs of conduit and cable. This offers flexibility, scalability, and cleaner installations in high-density environments. The busway is an alternative to traditional PDU and RPP power distribution. Let's move this up. Busway power distribution architecture typically includes an end-feed unit connected to an upstream low-voltage electrical switchboard, busway and tap-off units equipped with overcurrent protection, connection fittings, and their accessories. So it would look something like this, where you'd have your UPS connected to the end feed of the busway. And then it would run the length of the racks and have tap-off boxes over each section of rack with power drops to each rack. So let's move this up again. There are three main types of busways commonly used in data centers. Feeder busways. These deliver large amounts of power from the main switchgear to downstream distribution points like crack units or secondary panels. Then there's plug-in busways. These run above the equipment rows and allow tap-off units to plug in wherever the power is needed. This is ideal for fast-changing IT racks, and this is what I drew earlier. And then there's lighting or compact busways. These are used in office or support areas for overhead lighting or small loads. These are less common in data centers. Let's move this over. So why use busways? Busway systems offer an optimized power distribution system that can distribute and manage power capacity for current and future requirements. They have integrated branch circuit power metering, so capacity and redundancy are managed on every circuit. They're also flexible. You can reconfigure data center layouts by adding additional tap-off boxes or relocating existing tap-offs on the busway. They're hot swappable and plug-and-play. Let me move this up again. This means that circuits can be quickly added and removed while the busbar is live, which reduces data center downtime. These are two of the biggest drivers for using busways. They're also modular and above the racks, which means increased white space for IT equipment. And they provide improved traceability because tap-off units are located above racks and circuit protection is located exactly above the load. Let's move this up again. They're also pre-assembled, which eliminates field wiring and cutting and terminating branch circuits. And being overhead allows for an unrestricted cooling system. Busways are often seen in high-density data center applications, providing flexible overhead power distribution where scalability is vital to success. So let's bring all of this back on. If you have any questions or suggestions for future videos, leave them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next time.